we have a lot of postulates and theorems about parallel lines that you will need to memorize. All right? So first we're going to talk about what a parallel line is. It's two lines that are coplanar. What does coplanar mean from chapter 1? In the same plane, okay? And they do not intersect. All right? Skew lines are not in the same plane, so they don't intersect. And parallel planes are two planes that do not intersect. So if you open your book to page 147, you can kind of see some pictures of that. It has a blue plane and a green plane. On page 147, example 1, you see a blue plane and a green plane. And in the blue plane, there's two parallel lines that don't intersect. They're both in the blue plane. And then you have a line that goes through the plane. Those are called skew lines. They have to both be in the same plane to intersect and be parallel, okay? Or to not intersect and be parallel. So if you have two planes that don't intersect, they're called parallel planes. All right? So we've got some postulates, and I told you to get a highlighter, and I've given you a handout. I think at the very top of the page, it says postulate 13. It says the parallel postulate. So please highlight parallel postulate on your handout. If you don't have a highlighter, you can mark it with your pencil, check mark, whatever you want to do. Underline it, box it, color it, whatever. The parallel postulate, so you don't have to copy it because it's on your handout. That's why I got out highlighters, okay? So we can highlight and not copy as much. Sound good? Okay. So a postulate, parallel postulate says if there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. Okay? So if we have a line and then any point, then there is a line that goes through that point that makes me have two parallel lines. Okay? Right underneath that is the perpendicular postulate. So please highlight the perpendicular postulate as well. And also highlighting them lets us know which ones we've covered. It's kind of like a checklist. So by the end of chapter 3, we'll have covered all of these postulates on the handout. So the perpendicular postulate is the same thing, but with perpendicular lines. Now what do perpendicular lines do? Intersect to form what? A right angle. Good. So perpendicular postulate says if there is a line and a point not on the line, then there is exactly one line through the point perpendicular to that given line. All right, you do need to write down this definition of a transversal. This is the definition. Now, a transversal is a line that crosses two or more lines. Now, they're going to be coplanar, which means in the same plane. So, a transversal line crosses two other lines. Now, when we have two things called transversals, it divides angles into different categories. So anytime we have two lines with a line that goes through both of them, that's called a transversal, we get different sets of lines. So the first one we're going to talk about are corresponding angles. Okay? So please draw this picture. And actually, if you look on page 149, there's good pictures. So page 149 is something kind of important. In that blue box, it says key concept. So it might be handy to like take a picture of that someday. So when you're like sitting somewhere bored, you can find that picture and learn those things because they are very important to this chapter. So I've got two lines. They're not parallel lines, but they are both cut by transversal T. Okay? This line T is a transversal because it goes through these two lines. All right? So when it did, it made me have 8 different angles right here. All right? Now, angle 2 and angle 6 are in the same position of that transversal. Okay? It's on top of one of the lines, and it's to the left of the transversal. Same thing with angle 6. It's on top of the other line, and it's to the left, or it's actually to the right of the transversal. The transversal is to the left of it. They're in the same position. These angles are called corresponding angles. So corresponding means they're in the same position. Okay? Corresponding angles have corresponding positions. Highlight that because it's important. Again, if you want to like write down that page 149, their pictures are better than mine. All right, so the next one, if you're on there, they're all right there together on that page. We have alternate interior angles. And I will be quiet and let you go for a second. Page 149. I'll write that page number on the board. So that page 149, when you're doing your assignment tonight, it might be helpful if you put like a sticky note or some kind of bookmarker there because it would be easy for you to flip back and forth to. So remember that a transversal goes through two lines. They don't have to be parallel. Sometimes they are, sometimes they're not. But when it does, two angles that are on opposite sides of the transversal but between the two lines are called alternate interior angles. What does interior mean? The inside, right? If you're an interior decorator, you design inside of houses, right? Right. You're talking about the interior of a car. You're talking about the inside of a car. So alternate interior angles, alternate means they alternate positions. All right, so here's my two lines. Here's my transversal. Angle 5 and angle 4, alternate interior angles. Okay? Another pair of alternate interior angles would be these two angles. All right? They're on the opposite sides of the transversal, but they're still between those two lines. They're inside the two lines. Okay? Alternate interior angles. Likewise, we have alternate exterior angles. Interior means inside. What does exterior mean? Outside. All right, so alternate exterior are on opposite sides of the transversal. The exterior means outside, so they're not between the two lines, they're outside of them. So notice how this one's to the left of the transversal, this one's to the right. So these are alternate exterior angles. They're outside the two lines on opposite sides of the transversal. So likewise, these two angles right here are also alternate exterior. So these two are alternate exterior pairs of angles, and these two are alternate exterior pairs of angles. All right? So, and y'all, we're just going to have to memorize these. You're going to have to know what they look like when you see them. There's only one more set. One more kind. One more kind. And y'all, I know when we're starting a new chapter, it's a lot of writing because there's a lot of terms. But these are so important because we're going to start tomorrow doing proofs with parallel lines. And you've got to know these angle pair relationships. Does anybody know what the word consecutive means? Consecutive basically means one right after the other. Okay? Sometimes they're referred to as right next to each other. So if you're talking about to put something in consecutive order, that usually means the order that they go right next to each other. All right? So consecutive interior angles are on the same side of the transversal. Interior means what? Inside. So they're between the two parallel lines and they're on the same side of the transversal. So consecutive interior means they are right next to each other, one right after the other, on the same side of the transversal between the two lines. Okay? So these two right here on the other side would also be consecutive interior angles. All right? Now, how are we going to learn these? We're going to practice. We're going to practice. We're going to see lots of them, and you got to pick out that relationship. So that means, okay, here's what we got. There's four kinds. We have corresponding. That means same position. We have consecutive interior angles. Consecutive interior angles. That's what those are. Then we have alternate interior angles. And then alternate exterior. So there's just four kinds. Okay? All right, so anytime you say the word interior, that means what? Inside the two lines. Exterior means what? Outside the two lines. Consecutive means one after the other. Alternate means they swap sides of the transversal. Okay? Exterior means outside the two lines. Okay, draw this picture. Got two lines. And transversal T goes through them. And go ahead and label those angles. I'm going to give you a second to do that. I'll give you more in a second this time. So your notes won't make sense if you don't draw this picture, okay? So make sure you draw the picture. That's the important part right here. Make sure you put the numbers in the same position I put them too. So what we're going to do is we're going to use this picture to list angle pairs. All right, so number one wants us to list pairs of corresponding angles. So we're going to find all our pairs of corresponding angles, and there's quite a few. Then number two wants us to find all of our interior angle measure pairs. And next wants to find alternate exterior. Then last they want consecutive interiors. Okay, so we're going to list every pair that we see. So let's start with corresponding. Okay, let's start with corresponding. Now remember, what does corresponding mean? Same what? Position. So this is my transversal. So let's just talk about angle 1. Which other angle number looks like it's in the same position of this transversal as angle 1 is? 5. Very good. So one pair of corresponding angles is angle 1 and angle 5. So they're both on top of the transversal and to the left of one of those lines. Y'all see that? Y'all see that? Okay. So let's say angle 2. Which one do you think corresponds with angle 2? Angle 6. Very good. They look like they're in the same spot, just shifted over to the other line. Okay? Y'all see what I'm doing here? Now angle 3. Which one corresponds with angle 3? Angle 7. Very good. Angle 3 and angle 7. And last I have what pair? 4 is in the same position as angle 8. Almost said something. Angle 4 and angle 8. So do y'all see what I'm talking about with corresponding? They're in the same position. This goes here, this is here, this is here, this is here. You can almost do the finger dance. Alright? Alright, so that's corresponding. So next let's do alternate interior. Now what does interior mean? Inside the 2 lines, not the transversal. So here's my 2 lines. Alright? When I say inside, that means between them. So I'm not going to use 1, 3, 6, or 8. Y'all with me? Interior angles are 2, 4, 5, and 7. Alternate interior means they alternate positions. Here's my transversal. So if I have angle 2, which one do you think is the alternate interior angle pair? 7. They're on opposite sides of the transversal. Y'all see that? One's above it, one's below it. So angle 2 and angle 7 are alternate interior angles. I gotta watch my words. Okay, so 2 and 7. What other pair do you think are alternate interior angles? 4 and 5. Y'all are doing so good. So angle 4 and angle 5 are also alternate interior. What does interior mean? Inside, so between the 2 lines. Alternate means you swap positions. Okay? All right, so next is alternate exterior. What does exterior mean? Outside the 2 lines. So I'm talking about 1, 3, 6, and 8. All right? Alternate means what? Change positions. Right? So what do you think is the alternate exterior angle pair with angle 1? Angle 8. One's above it, one's below the transversal. Y'all see that? So angle 1 and angle 8. All right. So angle 3 is another exterior angle. Which one's the alternate exterior angle that goes with it? Angle 6. One's above, one's below. Y'all with me? So angle 3 and angle 6. Exterior means what? Outside. Y'all with me? All right. The last is consecutive interior angle pairs. Now, what does interior mean? Inside the two lines. Consecutive means in order, one right after each other, on the same side of the transversal. Okay? So, angle 2, we said, is an interior angle, right? So, what do you think is its consecutive interior angle pair? 5. They're both on top of the transversal. Do y'all see that? Angle 2. Ooh, I need my dark bold red. Angle 2 and angle 5 are alternate or consecutive interior. And what's the other one? Angle 4 and angle 7. So y'all are catching on. Okay? So knowing these positions is so important. So again, that page 149 will help you out. Okay? So when you're doing your assignment tonight, it might be handy to like keep a bookmark or a sticky note or something right there so you can flip back and forth. All right. On the bottom of page 149, I want you all to do 3, 4, and 5. It'll give you two angles numbered. Tell me what kind of angle pair relationship they have. Are they corresponding? Are they consecutive interior? Are they alternate interior? Or are they alternate exterior? So the bottom of page 149, tell me what kind of angle pair relationship do they have? The red angles. Okay? So write it on your paper and we'll check it in just a minute. You get all three of them, go ahead and check with somebody quietly. Good job. Anybody want to be brave and let me check? You did good. We have too many injuries going on in here. All right. Y'all look, let's go over them together, please. Number 3, angle 1 and angle 5. What's their relationship, guys? They are corresponding, which means what? In the same what? Position. Same spot, right? They look like they're in the same spot. That's corresponding. Raise your hand if you got corresponding for number 3. Very good. Number 4, angle 2 and angle 7. What kind of relationship do they have? Alternate what? Exterior. Raise your hand if you got alternate exterior. What? I got to make sure I spell it right. What does exterior mean? They're outside the 2 lines. Very good. And number 5, what's that relationship? Alternate interior. What does interior mean? They're inside the... Can y'all help me spell? Re-or. Okay. Is that right? All right. So raise your hand if you got all 3 of those right. A bunch of you did when I was walking around. Good job. That is actually the end of section 3.1. So we're going to get going into section 3.2 for a little bit. Ignore that. You're not doing that much homework. And the good thing is a lot of these notes are already on your handout. So get your handout. Go ahead and title the lesson. Section 3.2, use parallel lines and transversals. So section 3.1 kind of introduced us to those 4 relationships. And on section 3.2, we're going to actually find out what that means to us in terms of solving things. Okay, so now we're going to find out what we can do with those relationships. Okay, so you do not have to write down that postulate. It is on your handout. So you can find it on your handout and highlight it, please. Please write the title of the lesson. And you don't even have to draw the picture because the picture is there on the handout as well. So where is the corresponding angles postulate? Same side of the page, the 3rd one down, right? Okay, so it's about right there. Third one down. Now, we know that corresponding angles are when 2 lines are cut by a transversal, and corresponding angles are in the same position of that transversal, right? Same spot. Now, if that transversal is going through 2 parallel lines, then those 2 angle measures are congruent. Now, here's how we can tell by a picture if they are parallel. Everybody look up here real quick. You see these little arrows right here? Mine kind of look like triangles. Sometimes they look like arrows. Okay? So if you see 2 of them that have the same number of arrows, then those means those lines are parallel. So this line and this line are parallel. So it's 2 parallel lines. They're cut by a transversal. So if that happens, then corresponding angles are congruent. So angle 2 and angle 6 right here, whatever their measure is, it's going to be the same. If I know one, I know the other. So the corresponding angles postulate says if 2 parallel lines are cut by a transversal, then corresponding angles are congruent. Okay? So corresponding angles are congruent. That's important. You might want to highlight the word congruent on there as well. Corresponding angles are congruent. That's an important word in that postulate. So highlight the word congruent. All right, draw this picture. This one gave you a hint. I don't really like the hint, but they gave you one anyway. Are those 2 lines parallel lines? How do you know? They got a little arrow. Mine look like triangles, but they're little arrows, right? So these are two parallel lines, and there's a line that goes through it. What's the line that goes through two lines? Transversal. Look, you've already learned a word for today. New vocabulary.
Miss Isbell.
Yes.
Tell Chakra to come office, please.
All right. All right. So angle 1, they went ahead and told us that measure is 120 degrees. Y'all see that? So label your angles 2, 5, 6, 3, 4, 7, 8. We're going to find what other angles are also 120 degrees. Now we just learned that what kind of angles are congruent? Corresponding. So if this is angle 1 right here is 120 degrees, which angle corresponds to that angle? Angle 5. Y'all see that? Y'all see that one? They're in the same position of that transversal, so they're both going to be the same measure. Right? Mm-hmm. Go ahead. Very possibly. Very possibly. Y'all, this is an important ACT skill. ACT asks you a lot of questions like this. Okay? Do y'all know that the ACT test, the math part's 38% in geometry? More so than any other math subject you'll take. 38% is more than a third of the test. Because the third would be 33.3%. Right? It's pretty dang important to you getting money for college. Alright? So, do y'all understand why angle 5 is also 120 degrees? Okay. There's actually two more that are also 120 degrees. Okay. Why would angle 4, do you think, be 120 degrees? Do what? So that's kind of like congruent supplements too, right? That works. But I'm thinking of something similar. What did we talk about in chapter 2? Vertical angles are congruent, right? What's a vertical angle mean? It's across from it, right? So if this one's 120 degrees, then angle 4 is across from that, so it would also be. So y'all, I told you what we learned in one chapter in geometry carries over. You can't forget nothing. That's a double negative, but I mean it. You can't forget anything. Okay? We repeat it, repeat it, repeat it. All right. So, likewise, if this one's 120 degrees and this one is. Yes?
I have a lesson to come to office.
Okay. Y'all with me? Vertical angles again. If this one's 120 degrees, then this one is also 120 degrees because they're vertical angles. But look at 4 and 8's relationship. What are 4 and 8's relationship? Corresponding angles, right? So after I got that one, I could also get this one. So I could do vertical angles or corresponding angles to get angle 8. Does that make sense? How are we going to get good? Practice. We're going to see it over and over. So list all my angles that were also 120. Yeah. In any order. Any order is fine. So do y'all see how I did it? So I use corresponding and I use vertical angles to help me get those. All right. Good job. Yeah, like so I could technically find what the measure of angle 2 is, right? Yeah, it's going to be 60 because those make a line. So if this one's 60, then this one's 60, and that corresponds with this one, so this one's, and that's vertical with that one, so it has to be 30. Do y'all see how we got those? Y'all see how we got those? Linear pairs equal 180. So if I know this one's 120, this one has to be 60. So together they make 180. And again, you can do vertical and corresponding to get those. So we just solved all of those angles because we're smart cookies. All right. Highlight on your handout, please. Find alternate interior angles theorem. This one is a theorem, not a postulate, because it has been proven. It's actually toward the bottom, isn't it? Mm-hmm. Yeah, it's on the bottom. Theorem 3.1, alternate interior angles theorem. Y'all see it? Toward the bottom where it says theorems, it's the first one. So highlight that one. And it says if two parallel lines are cut by a transversal, then alternate interior angles are what? Congruent. Highlight the word congruent. It's an important word. So we know so far that corresponding angles are congruent and alternate interior angles are congruent. Cool stuff. So if I know angle 4 and angle 5, if I know one, I know the other. They're congruent. All right. On the sheet. Next one down, Shirley. Yep. Alternate exterior angles. If two parallel lines are cut by a transversal, then alternate exterior angles are what? Congruent. So corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. But consecutive interior angles will not be congruent. They're the oddball. Can I scroll? So highlight exterior angles theorem and then highlight the word congruent. Spoiler alert, you can read the bottom theorem. Consecutive interior angles are what? What does supplementary mean? They add to make 180. Memorize, memorize, memorize. Corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. Consecutive interior angles are supplementary. So if angle 3 is 20 degrees, then angle 5 has to be 160 degrees. Y'all see that? Okay. So, now we get to do a little math. Bum, 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 bum. Draw that picture and fill it in. That's angle 4, not 4 degrees. You can tell the difference because degrees have degree symbols. If it don't have a degree symbol, it's just the name of that angle. Sorry, let me freeze that because I want to see how much further we're doing. Not too much. Oh yeah. Including this one, I have 3 more examples, including this one. So easily. Yeah, that's an X. So that's 115 degrees, and this one is X plus 5 degrees, and 4 is just the name of that angle. All right. So what we need to use is our angle pair relationships. Now we got to see if there's one that exists. Okay? Is there an angle pair relationship that exists between this X plus 5 degrees and this 115 degrees? Are they in the same position? Nope. So they're not corresponding, are they? Are they both exterior? So they can't be alternate exterior. Are they both interior? No. But do I have a relationship between 115 degrees and this angle 4? What is this relationship? It's not one of them on the board. It's one which you already know. Vertical angles, right? Because they're across from each other. So if this is 115 degrees, then angle 4 is also what? 115 degrees because they're vertical angles. Now, is there a relationship between these two? What's this relationship? Are they alternate or are they consecutive? Consecutive because they're on the same side of the transversal, right? Interior because they're between the two lines. They're on the inside. Consecutive because they are in the same side of the transversal. One comes after the other. And what did we just learn? Consecutive interior angles are what? Supplementary. What does supplementary mean? They add to make 180. So if I want to find what x is, I'm going to say x plus 5 plus 115 degrees equals what? 180. Y'all with me? I had to get vertical angles here to get it right here because these two did not have a relationship. All right, so I use vertical angles to move this one here, and these come right after each other on the inside, so they're consecutive interior. And we just found that means they're supplementary, so they sum to make 180. All right, solve that for x. First of all, these two are like terms, correct? What's 5 plus 115? So x plus 120 equals 180. Now what? Subtract 120 everywhere. X equals, and you can check it. 6 plus 5 degrees is 65 degrees. Is 65 plus 115 equal to 180? I believe so. So any questions on how we did that? So use your angle relationships. You might have to use vertical angles as well. This one's easier to me. Draw that picture so your notes make sense, please. After this one is a you try, and then we're done. Somebody just crashed. Are those lines parallel? Yes, because I have the two arrows. All right. So it says to find x. So there's x down there. Do these two angles have a relationship? Say it, Caleb. They're corresponding, right? They're in the same position as each other. They're in the same spot. Y'all see that they're corresponding? All right, so our handout tells us that corresponding angles are what? Congruent, which means they have equal measures, right? Right? So to solve for x, do I set them equal to 180 or equal to each other? Equal to each other. Very good. Y'all see how we get that? This and this are corresponding, which means they're congruent, which means they have equal measures. So I can say 135 equals x minus 30, or I could swap the order. That would be symmetric property, right? So I add 30 on both sides. What's 135 plus 30? 165 equals x. And you can check it. Is 165 minus 30 degrees 135 degrees? It is. So since they're corresponding, we can set them equal to each other. So alternate interiors, alternate exteriors, and corresponding you can set equal to each other. Consecutive interiors, you need to set them equal to 180. Okay, add them and set them equal to 180. All right. This one's a little bit different in its setup. So I'm going to go ahead and plug in what they told us. They told us that angle 3 is 68 degrees and that the measure of angle 8 is 2x plus 4 degrees. Couple of ways you can go about this one. Couple of ways. I said this was a U-try, but I'm going to start us out and then y'all can finish it. Y'all look at me when you get it copied down. Or look at the screen at least so I know that you're trying to figure something out. All right, so if I know angle 3 is 68 degrees, do I know any other angles that are also 68 degrees? Angle 2, because they're what? Vertical angles. What else? Do what? 7, because 7 is alternate interior, right? And 6 is also because it's a vertical angle with that one. Or you could say corresponding and corresponding, right? So what are we going to do with this one that's with X? Why are we going to use 180? Well, what do these two angles do? They make a line, right? They're a linear pair. So I can say this plus this equals 180. So that's what I want you to do. 2x plus 4, bless you, plus 68 equals 180. I want y'all to solve that for x for me. Y'all say y equals 180? Yeah. So sometimes it just takes you plugging in which ones you know all over the place so you can figure out if you're going to set it equal to something or if it makes a line. So I want everybody to solve that for x, please. All right, so 4 and 68 are what? Like terms. What is 4 plus 68? So 2x plus 72 equals 180. Then what did you do? Subtract 72. What's 180 minus 72? 108. And then you divided by 2. And what did you get? 54. Raise your hand if you got x equals 54. And then you can check it. 2 times 54 plus 4 minus 180 or equals 68. Okay, so I'm going to stop right here. That's the end of section 3.1 and 3.2. Have a good day.